to be or not to be a function? That is the question of this video. Thanks, Shakespeare. Alright, the first thing that we're going to talk about is the vertical line test. And this is what is used to determine if a function is a function or not a function based on a graph. So this graph here represents a function. So what I'm going to use is what's called the vertical line test to determine if this forms a function. So what I'm going to do is draw a vertical line, and you guys in class can use rulers or you can just draw your own vertical lines. And in order for this to be a function, this line can only cross the function at one point. So no matter where I move this line, it's only crossing the function at one point, whether it's here or here. This line is considered to be a function. Looking at this function here, as I move my vertical line throughout the function, it only crosses the function at one point. Let me show you an example of something that's not a function. If you notice here, when I draw my vertical line, it hits the function at 2 points. 1, 2. So this is considered not to be a function. So let's look at your graphic organizer in a minute, and then we're going to look at a few more examples here. So if I move my vertical line over my circle, it hits the function at 2 points. So this is considered to be not a function. As I move my vertical line over this function, it only hits the line once. So this is considered to be a function. And then as I move my vertical line over this function here, it still only hits my function at 1 point. There's no spot on the function where I can draw a vertical line where it hits it twice. So this is also considered to be a function. Now let's visit your graphic organizer. Again, if I draw a vertical line on my function here, I'm just going to use a highlighter. No matter where I draw that vertical line, it only crosses the function at 1 point. So this is considered to be a function. Whereas if I draw a vertical line on this function here, it crosses my function at 2 spots. 1, 2. So this is considered to not be a function. So in order for it to be a function, the vertical line test can only pass through the line once. Whereas if it's not a function, you can use the vertical line test, and it passes the line more than once. It should be once. Now, you can also determine if it's a function from a mapping diagram. So we discussed mapping diagrams in the last video. In order for it to be a function, each domain or input can only have one and only one output. So -1's output is 5, 0 is 3, 1 is 5, 2 is 11, 3 is 21. If you notice, each input or domain only has one output. Yes, you can see here that each of these inputs both have the same output, but it's still considered a function, because if you look at this mapping diagram here, 15 has more than one output, therefore this is considered to not be a function. So it's only if the domain has more than one output. I want you to circle this on your graphic organizer. Now the next thing we're going to talk about is if a function is linear versus nonlinear. This is something we talked about in 7th grade. but this is a quick review. So a linear function shows a constant rate of change. So if you notice here, my x values increase by 3. My y values decrease by 8. So the rate of change is constant. Therefore, this is a function that's linear. Now, yes, this increases and this decreases, but it's the same increase for my x, and it's the same decrease for my y. Therefore, this is considered to be a linear function. Now, a nonlinear function does not have a constant rate. While my x values increase by 2, my y values increase by 9, 22, and 55. That is not constant, therefore this function is nonlinear. There's also another way to determine if a function is linear or nonlinear. Oh, we're frozen. Wonderful. Okay. So this is a even more simple way to look at it. If you look at the word linear, you'll see the word line. So in order for a function to be linear, the graph has to form a line. So the graph is a line, so this function is linear. Whereas a non-linear function is a non-line, or the graph that does not form a line. So this graph is not a line, so the function is nonlinear. Here's a couple other examples. This would be linear, because it forms a straight line. This is nonlinear, therefore it does not form a straight line. This is also nonlinear, it does not form a straight line. And this is an example of a linear function, because it forms a straight line. Now let's visit your graphic organizer on linear versus nonlinear. So again, a linear function from a graph. The linear function has a graph that is a straight line, whereas a nonlinear graph is not a line. Now looking at a function table, if you notice here, my input values decrease by 2, and my input values increase by 3. So therefore, this is considered a function. On this function table, my x values increase by 4. But if you look at my y values, they decrease by different amounts. -3 to -5, I'm subtracting 2. -5 to -10, I'm subtracting 5. And -10 to -12, I'm subtracting 2. Now you might start to see a pattern, but this isn't constant. It has to increase or decrease by the same number. All right, this concludes your video on determining if something's a function or not a function, as well as something that's linear versus nonlinear. Now you can have a graph that's nonlinear, but still considered a function. So if I apply what we learned about in the beginning of the video, this line passes the vertical line test. Therefore, this is considered to be a function, but it's a nonlinear function. All right, if you have any questions, please make sure you ask them in class tomorrow, and I will see you then. This was great to teach you. I think I just changed it to my accent. I'm not really sure what it is.